In 1981, official silence covered the rural regions of Japan. The crested ibis, the thousand-year symbol of this nation, was declared completely gone from the wild. But a miracle appeared from a remote valley in China: 7 surviving birds. This was the only hope for reviving a species that had stood on the brink of extinction. Immediately, an extremely risky strategy was carried out. Japan brought these precious descendants back into the very rice fields filled with high-dose pesticides. The toxic chemicals had once wiped out their food sources and erased their ancestors just a few decades earlier. But nature flatly rejected this destined verdict. Instead of being exposed to chemicals once again, this bird species carried out a classic ecological counterattack. They began restructuring the entire agricultural chemical system and forced an entire island to change the way its economy operated. Why did the rice fields that once fed them turn into exhausted lands filled with chemicals? What terrifying secret was hidden beneath this poisoned layer of mud? By 1981, observation data from the Japanese sky recorded a shocking number. The wild crested ibis population had fallen from tens of thousands to exactly 5 old and weakened individuals on Sado Island. From a creature that had ruled Asian wetlands for thousands of years, this bird with royal pinkish-white feathers suddenly vanished completely from human sight. This collapse did not happen naturally. It was the result of an invisible chemical war. After World War II, the global hunger for food activated a campaign to maximize agricultural productivity. High-intensity synthetic chemicals, especially DDT and BHC, were poured onto the fields. They performed brilliantly in eliminating harmful insects, but at the same time severed the food chain from its roots. Small aquatic animals such as loaches, frogs, and freshwater crabs, the core nutritional source of the crested ibis, were swept out of the ecosystem. More seriously, the phenomenon of bioaccumulation devastated the reproductive structure of this bird species. Chemicals seeped into their bodies, disrupting hormones, making the eggshells so thin that a mother bird only needed to incubate them to crush the hope of the next generation. Without food, without the ability to reproduce, the last 5 individuals on Sado Island were like flying ruins waiting for the day they would fade away. The future of this species seemed to have been nailed into the red list, with no way back. But nature always has a way of hiding the final pieces in a place no one expects, leading to an intervention of geopolitical scale. Conservationists immediately intervened with the first-generation solution, capturing the final 5 individuals and placing them inside a strictly protected center. Contrary to expectations of recovery behind glass, forced breeding failed disastrously because of deep inbreeding. Their genetic structure had become too old and degraded. The last pure Japanese individual, named Kin, stopped growing at the most desperate moment, completely ending the native bloodline. But at the very last minute, global ornithologists received an unbelievable report. The last 7 wild crested ibises on Earth had been discovered hiding in a remote valley in Shaanxi Province, China. An unprecedented ecological diplomatic treaty was established. China agreed to transfer this precious genetic source to Japan for cooperative breeding. However, when scientists received the first hybrid individuals, they discovered a troubling truth: the entire future population would have to be born from the extremely narrow gene pool of exactly 7 original individuals. This limitation in genetic resources meant that hundreds of later birds would carry almost identical genetic codes, turning them into organisms extremely sensitive to the environment. Now place yourself inside an extremely harsh challenge. You are holding the creatures with the weakest genetic code on the planet. Would you continue pouring tens of millions of dollars into laboratories to keep them alive, or let go and allow natural selection to decide? Comment your choice. Because the next decision made by scientists would certainly shatter all ordinary logic. With the hybrid generation in hand, Japan immediately faced a decisive question: where should they be returned? When their natural home was still fields cultivated under industrialized farming. Releasing birds raised on industrial feed back into a landscape empty of natural food was a decision that would eliminate itself. Computer models showed that this would only create a population permanently dependent on human support. At this moment, a breakthrough scientific perspective appeared, completely changing the way humans practice conservation. Do not focus on the bird, redesign the economy of the island. The intervention campaign was activated through a new agricultural standard called Toki rice. Instead of applying a total ban that would damage the economy, this model required farmers to cut exactly half of their synthetic chemical use and completely stop using herbicides along field edges. In return, the entire irrigation system of the island had to be redesigned according to the strictest ecological standards in order to restore the natural habitat. Recent microbiological data proves the power of this method when farmers applied the technique of keeping fields flooded throughout winter and digging deep water channels along field edges as shelters for aquatic animals. The soil microbiome immediately recovered. The winter organic decomposition process created a massive food source for red worms, which then triggered an explosion of loaches and frogs when spring arrived. The food chain was reconnected from its smallest links. The core challenge was how to protect this rare bird species when they hunted directly on fields that still contained chemical residues. The solution introduced was the technique of ecological spatial layering. By taking advantage of the farming cycle, when field surfaces were drained in summer and surface toxin concentrations surged, a natural survival mechanism was immediately activated. At that exact moment, small aquatic species such as frogs and mudloaches would automatically migrate down into the deep water channels along the field edges to avoid the heat. This movement completely separated the bird's food source from the dangerous muddy zone. When the flock landed, instinct would guide them straight toward these clean water channels, where the entire safe biomass was concentrated. This spatial manipulation technique created an absolutely safe feeding zone inside a chemical encirclement. Instead of cleaning up the toxins, humans only needed to precisely guide animal behavior. Theory on paper is always perfect, but when the survival of the first 10 birds was released into the mud of Sado Island, the line between brilliant success and total disappearance was separated by exactly one farming season. 10 individuals were the decisive pioneer team enough to monitor, while still limiting the risk of total extinction. This project did not call for compassion. It struck directly at economic interests. To turn thousands of farmers into an ecological protection force, the government turned the ecosystem into a financial lever. Rice certified as Toki-friendly was priced far higher. On the same area of land, rice grown with 50% fewer chemicals was sold at 1.5 times the price of ordinary rice, while fully organic rice reached prices many times higher. Local authorities established financial support funds to secure farmers' income during the high-risk transition period. At the same time, a synchronized digital biological monitoring network was deployed. Farmers were equipped with mobile devices to record the coordinates where each individual bird appeared, turning them into field observation stations that continuously transmitted data back to the central server. At this point, the GIS network operated no differently from a campaign command center. The data fed into it created a real-time heat map, accurately scanning the coordinates of each bird feeding ground. For the first time in history, the behavior of a wild species was converted directly into financial data. The location where the birds appeared was mapped directly onto the profit chart of each rice field. A circular economic model was formed when farmers' income became proportional to the frequency with which this bird species appeared in their rice fields. The reaction from the consumer market far exceeded expectations as multinational corporations and premium airlines quickly signed product purchase contracts. Ecological agriculture officially became an industry that generated enormous added value. In only a short period of time, nearly half of the island's cultivated area had completed the ecological transition process. Strong financial motivation pushed the local community to personally dismantle artificial concrete embankment systems and restore the original geological condition. This deindustrialization process took place entirely voluntarily thanks to the powerful push from market demand. When machinery withdrew and chemicals gave way to flooded water, a natural force rose up at a speed that shattered every supercomputer prediction model. But along with that dizzying recovery speed, the island was also moving closer to a new critical point. Recent recorded data has confirmed a great ecosystem reversal. The wild population exploded beyond control. From 10 experimentally released individuals, the sky of Sado has now witnessed more than 500 individuals spreading their wings in flight. The bird species that had once been completely absent now breeds naturally in the treetops, forcing conservation agencies to officially remove it from the level of extinct in the wild. Contrary to ordinary ecological prediction models, the presence of this mid-level predator created a chain biological stimulation effect. The biodiversity index in the area rose sharply as a series of endemic amphibians and insects began to re-establish their populations. The restoration of the rice field ecological structure led to a sudden increase in the commercial value of the entire region. An estimated 50,000 international and domestic tourists flock to this island every year just to observe the legendary bird species. From lodging services and restaurants to retail, the presence of the toki bird directly pumps about 4.45 billion yen into the regional economy each year. Sado rice became a luxury product sought after by high-end restaurant chains. A creature that was once a victim of development has now become an asset-generating machine for the entire region. Independent research organizations have cross-checked this result through space-based remote sensing technology. Multispectral satellite imaging systems prove a clear improvement in surface moisture and the growth of shoreline vegetation compared with neighboring areas. This physical transformation persuaded international organizations to grant certification, honoring the farming system here as a global benchmark model. Data from this organization proves that restoring the water architecture here did not only save a bird species, but also reset the carbon cycle and regulated the microclimate for an entire region. Yet, if we look past this perfect outer shell, commentators and genetic scientists are pointing out three fatal risks that are rarely mentioned. First, the hidden genetic danger. Because the entire current population was developed from only one genetic source, its genetic diversity is at a red alert level. The uniformity of the immune system turns this bird species into the most vulnerable target against any new virus variant. In addition, the sustainability of this model depends completely on surplus value from premium agricultural products. A global financial crisis could completely collapse purchasing power, forcing the farming system to return to chemical methods in order to optimize costs. More than that, the population explosion of this bird species is creating negative impacts on crop yields. Hundreds of adult individuals damaging seeding areas are creating new tensions between conservation efforts and human livelihoods. It is a great victory for intervention science. A perfect happy ending? Everything seems to be that way, but even the most successful intervention is always waiting on the edge of collapse. Hidden beneath the dazzling cover of success is a cold warning from molecular biologists. The current population of 500 individuals on Sado Island is walking on extremely thin ice. Because all of them share the same origin from 7 individuals in China, their genetic diversity is almost zero. They share the same immune system. This immune fragility turns the entire population into a brittle structure. If a pathogen crossing over from neighboring areas enters, decades of conservation achievement could be completely neutralized in an extremely short time. However, this event still provides an invaluable reference dataset for environmental recovery models around the world. We cannot fix an ecological breakdown simply by cloning organisms behind glass and throwing them outside. An ecosystem is a complex interwoven machine. When you remove a core gear, the machine stops working. But if you return that gear, while also readjusting the economic engine that drives human behavior, nature will automatically restart. Although humans are the agents that caused environmental collapse, calculated intervention based on economic incentives has proven the ability to reverse the situation. Even so, ecosystem restoration is not a campaign with an ending. Artificial biological systems require continuous risk management and constantly adaptive solutions from scientists. Do not forget to hit like, subscribe to the channel, and turn on the notification bell so you do not miss the next ecological files. In the next video, we will continue opening a new ecological battlefield where a bold human intervention decision accidentally awakened a fierce natural force. The next incident will go even beyond your imagination.